Morning all, my name's Jyuoti and I work, so Francis spoke to us day before yesterday about the Met for Tech project, which is kind of looking at how do we build a circular economy in all of the critical technology metals that we're going to need if we actually want to achieve the sustainability goals, that we're all aiming for, all of the net zero targets that we're aiming for and things. So we're studying a slightly ironical question, because what we're actually saying is if we want to reduce our greenhouse gas emissions, if we want to achieve our climate change ambitions, we're perhaps going to need a little bit more of the mining of some specific material to do it. So it's really important for us to work out how are we going to do this properly in a way that actually gives us a net benefit rather than just lots of unintended consequences. So I'm kind of, I've been helping out with the circular economy workshop. And what I found really interesting was there hasn't been a lot of mention of the role of law and regulation in achieving a circular economy or achieving the sustainability goals that we're all aiming for. So I thought that might be an interesting thing for us to focus on today. Does the law have any role at all to play in achieving the circular economy that we want to achieve? And if yes, what role does it have? What should we be doing? So I have been, a lawyer working for the last 4 years in very science-based projects, all of them around, science and technology to deliver a green future, green technologies. And so I've gotten really fascinated by how do we frame regulations? How do we frame laws that actually work to govern science effectively? Do regulators understand evidence enough? Do the people who are coming up with the evidence, do the scientists understand what regulators are really doing and what impact it has on their work? So how do we get law and science to work together to deliver the same goals that we're all working towards? As part of this project, I've worked for a long time with lots of regulatory agencies, so the Environment Agency, with DEFRA, and I have real sympathy for them because I think they do a pretty hard job trying to strike a balance. The trouble with regulation is everybody wants very different things from regulation. So industry wants very different things from regulation than what an environmental activist would want, for example. Somebody might be in favor of very rigorous environmental regulation. Somebody might want regulation to be relatively light. Scientists particularly feel very hampered by having to adhere to too much regulation, because when you're innovating, when you're trying to develop new technology, the view that they might take is you've got to take a few risks and you've got to allow us to take a few risks with this. But green technologies particularly, the electric cars and all of those new kind of things that are going to clean up our world, they also come with lots of unknown risks. And one of the things that law asks you to do, if, for example, something went wrong with technology and somebody got hurt or property got damaged, one of the questions the law will ask is, were you able to foresee the risks? And if you were able to foresee the risks, did you take enough care to safeguard against them? But what do you do when a technology is completely new? What are you supposed to be able to foresee? How much should you be able to foresee? Can we understand the level of risks that we're dealing with? Should we be allowed to put these new technologies out because they've got sustainability advantages? Or should we be also worrying about the safety implications of some of these technologies? And how should the law evaluate this? So I think these are all problems that are going to come. They're going to come up in the law soon when things start to go wrong. It might be with EVs, it might be with artificial intelligence, it might be with regulating robots. We have some really complex questions that I think are going to come up with courts in the next decade or so. And what should we be prioritizing? What should lawyers be prioritizing when things go wrong? What should we be doing when safety, for example, compromises sustainability, or when sustainability, creates all kinds of new risks? So like I said, not everybody likes regulation. I was at a batteries conference in India about 3 weeks ago, and a scientist, so this was a lithium-ion battery scientist, the batteries that go into EVs, and he says to me, regulation is such a nuisance. We're trying to do something so incredible here. We're trying to build these great new batteries that are going to save the world. they should keep their hands off us for some time. You know, things might go wrong, things might blow up. There's particularly lots of EV batteries blowing up in India because EV batteries can't cope with very high temperatures. There's been a recent heat wave in India. There isn't a lot of protection. You know, there aren't very good protection mechanisms for people who might be injured by these. But lots of scientists might see regulation as a bit of a nuisance. And it's not just scientists. So the question really is, where should regulators sit? You know, should regulators be allowing innovation to carry on unhampered for a little while so we can achieve our climate objectives? Should regulators be regulating industry, or should they allow industry to get on with what it's doing because of the economic benefits of industry? You know, industry creates jobs, industry does all sorts of wonderful things to make our world better and brighter and, you know, more full of things. Should we be regulating industrial innovation? So there's some common criticisms of regulation. Not a lot of people like regulation. You know, it's sometimes seen as being too expensive, too much red tape, too many forms to fill. It stifles economic growth. It reduces profits. It hampers innovation. It stops scientists from getting on, you know, building clever new things. It hurts competitiveness and all sorts. You know, the list goes on. But not a lot of people like regulation. So I'm going to use an example that was actually given at at an event by the chief executive of the Environment Agency on why he does what he does and why he believes in what he does. And that resonated with me because for me, when I came into the law, 10 years ago, this was the exact example of why I believe in health and safety law, even though it's sometimes a little bit of a nuisance and it's sometimes, you know, a little bit boring. Is because I think if you live in a world where regulation doesn't work, it probably helps you understand the value of regulation a lot better and how important it is. So, you know, the Telegraph headline from 2021, this was, post-Brexit Britain should light a bonfire of EU red tape to fuel economic growth, say MPs. And we've got a picture there of David Cameron sitting in an EU summit in 2013, the whole agenda of the summit being, let's get rid of regulation and let's get rid of red tape and let's all carry on, you know, developing and growing. So there are a lot of people who don't like regulation. So what's the purpose of regulation? What should regulation be doing? Why do we need it? So I'm going to give you an example, right? Imagine a city where hundreds of thousands of people live. In the center is a huge industrial plant which produces chemicals. One night, there's a great big explosion in the plant. A deadly gas settles over much of the city. And by morning, thousands are dead. In the decades that follow, many thousands more die from the effects of the gas or from birth deformities. Hundreds of thousands more have their lives ruined, and the land and water around the plant are poisoned. Now, this scenario might seem like a bit, you know, something out of a movie, seem a bit fantastical. It isn't. This actually happened. I was very young. I lived pretty close to where it happened. This is the worst industrial disaster, that we've had in the world, the Bhopal gas disaster, which happened in 1984. There was a big leak in the chemicals factory, and there was, typically, what happens is you have little shanty towns that come up around big factories like that. You know, the poorest people are the ones who live closest to the plant. It's the workers, the factory workers. And there was a leak in the factory. 40 tons of very, very toxic methyl isocyanate was released from the Union Carbide plant. 500,000 people were exposed. 3,000 of them died within that one night. So in the morning, you woke up, and although I was very young then, the pictures never leave me of the newspapers, which is streets strewn with corpses. And the effects of this continue today. The plant is still there, derelict, but still there. There's never been a cleanup of all the toxic emissions in the water, in the soil, in the air. There are ongoing, even now, till today, ongoing birth deformities, miscarriages, stillbirths, cancers, lung and heart disease, which are a direct consequence of that disaster that happened over 30 years ago. Since then, over 20,000 more people have died from associated conditions. The mortality rate for people who were exposed to this is far, far higher even now. And like I said, the site still contains hundreds of tons of toxic waste and residues. People are still drinking the contaminated water because no one has taken the responsibility for cleaning it up. What Union Carbide did was to sell this on to another company. So Dow took the plant over. And then that led to lots of legal wrangles about, when you take on a company, we don't necessarily take on the liabilities. And so in the game of passing the buck, nobody's taken on the liability for cleaning up the plant properly. And so what this is an example of is what happens when regulation fails? What happens when regulation doesn't work? What happens when you don't have good enough regulation? And this is the reason why we need regulation. Both from the point of view of safety and from the point of view of sustainability to achieve the goals that we want to. So really, this is why I believe in regulation. And why is this important? So what I particularly wanted to talk about today was how should the law be regulating new technologies? Because those are the ones that come with, like I said, all kinds of unknown risks, all kinds of unintended consequences. But technology is going to be the key driver of our green, it's seen in the UK as being the driver of our green transition. The UK has some very progressive environmental targets. It was the first country to set out legal targets for reducing greenhouse gases. So way back in 2008, the Climate Change Act in the UK set up legally binding targets to reduce greenhouse gas emissions by 80%. That was then, made even more ambitious. In 2019, that was amended to the UK government having a binding target to achieve net zero by 2050. So not by 80%, but we now want to reduce greenhouse gas emissions by 100%. And so in 2020, we then came up with a 10-point plan for a green industrial revolution. This is how we're going to achieve our net zero target by 2050. And out of the 10 goals of the 10-point action plan, 7 of them completely relied on technology. So, whether it's one of them referred to EVs and the target to increase EV rollout, wind turbines, wind power, fully 7 of them are going to need lots and lots of new technology if we want to achieve our net zero targets. So really, none of those technologies are going to be possible without technology critical metals. We need the lithium and the cobalt and the nickel and the rare earths that go into making those green technologies. Now, the World Bank projects that our climate ambitions alone are going to lead to a huge rise in the demand for metals. EV and energy storage alone is going to lead to more than a 1,000% growth in demand for metals by 2050. And just by way of an example, people have spoken about this in previous presentations, but for EV batteries, the EU is going to need 18 times more lithium by 2030 and 60 times more lithium by 2050. So that's how rapidly the demand is going to grow for technology metals. A typical electric car cleans up the air, much better for the environment, but it requires 6 times the mineral inputs of a conventional car. An onshore wind plant needs 9 times more mineral resources than a gas-fired plant. So all of these new green technologies are also going to lead to an associated demand for more stuff. We've not got our recycling processes quite in order yet to get those metals out. As an example, less than 3% of rare earth minerals are recycled because it's just so hard to recycle them and effectively get good grade metal back into the value chain. So the European Commission is so concerned about these critical metals that for the last few years, they've been releasing year on year a list of metals that they believe are at real threat of future supplies. That list has grown from, the list contained 14 metals in 2011 that they were concerned we're not going to have enough of soon. That list within 9 years has grown to 30, so it's almost doubled in 9 years, which means more and more metals are becoming worrying for future supply. The supply of these metals is also very concentrated. They come from very few places around the world. So China provides 98% of the EU's supply of rare earth elements. Turkey provides 98% of the EU's supply of borate. South Africa provides 71% of the EU's need for platinum. So if anything was to happen to disrupt that one supply chain between those two countries, effectively, they'd be left without a supply to keep on building the EVs and the wind turbines that we need. So although the UK did really well to formulate policy to deliver net zero targets, what they didn't do until very recently was to think about where are the future technology metals going to come from? Where are we actually going to get the metals to continue to build all this stuff? It wasn't until the 2021 UK government net zero strategy that critical metals even got a mention in policy in the UK. So that only happened last year. There's now quicker momentum. In 2022, we've got the Critical Minerals Intelligence Centre being set up, the UK Critical Minerals Strategy coming up. So there's now a momentum. But what has happened is that the UK has fallen behind other countries because lots of other countries have been in there worrying about this issue and trying to solve future problems of supply for a lot longer than we have. So the USA, for example, has a Strategic and Critical Metals Stockpiling Act. They've been building strategies to be able to hold on to critical metals since the last 5 to 6 years already. The EU similarly has been paying a lot of attention to this issue for the past 5 or 6 years. We have quite some catching up to do. So that's our challenge in Med4Tech. How are we going to continue to provide the minerals to manufacture these green and digital technology products? And it's not just for EVs. Every time we want to update to the snazziest new smartphone, when we want the new laptop that we want, there's lots and lots of minerals that go into making those. There's lots of lithium and cobalt and nickel that we need to continue to manufacture these. Where's that actually going to come from? So obvious answer perhaps might be more mining, but like we've spent the last few days talking about, there's lots of social and environmental implications of mining. And so we are not going to be able to continue to do this responsibly unless the mining is also supplemented by circular economy approaches that help us get the metals out of the products and back into circulation again. And we haven't got good enough at doing this yet. So how can law and regulation help to facilitate a circular economy? The challenges with EV batteries, how do we build a sustainable and a safe EV transition? So not just one that achieves climate goals, but also does so safely. And what are the legal difficulties in governing new technologies? What are the dilemmas of governing completely unknown risks and completely unintended consequences? Will traditional legal principles actually work in this new landscape? Because we're evolving, and technology is evolving very, very rapidly. Are the old legal principles going to work, or do we need to start rethinking the law again and how these challenges are evaluated? So the EV transition is well underway already. There's 11 million EVs on the world's roads, is projected to rise to 145 million by 2030. Same in the UK. The problem that we have is we're not quite sure what we're going to do with these EV batteries when they're no longer able to provide traction to an EV. So when the batteries retire, we have no clear idea of how we're going to be handling them. And why is this a problem? So an EV battery is actually the costliest component of an electric car. By way of example, a Jaguar I-Pace costs about £70,000 if you bought it new. The cost of the battery is in the region of £35,000. So you're paying almost half of that money for the battery alone. It is a very costly component. The diagram there shows you how big an EV battery is compared to a traditional vehicle, where in a normal internal combustion engine vehicle, the battery just sits somewhere in the front engine, but the battery in an EV is far bigger, takes up a lot of space. It has a huge environmental cost to manufacture. It's full of valuable minerals. But the thing is that when an EV battery retires, when it can no longer move a car, it's still going to have 80% of its capacity left. So although it can't move an electric car, there are lots of things that leftover capacity could be used to do. So also, these batteries are large, they're powerful, they've got loads of residual capacity. They're at very, very high risk of explosion and toxic fumes if they're not managed properly, if they're just abandoned somewhere or if they go into landfills and so on. What we really want to be able to do, of course, is to be able to extract maximum value from the batteries. We want to be able to put it to another kind of use so that the remaining capacity can be used up. Alternatively, we want to be able to recycle the battery so we can get all the cobalt and lithium and nickel out and use it to manufacture more batteries rather than keep mining. But there are lots of difficulties recycling these batteries. So these batteries, not all EVs have the same kind of battery. EV batteries vary highly in their chemistry and their design and their packaging. So they're very, very difficult to recycle. They're not designed for end of life. That is one of the biggest problems. Lots of them are held together using really strong glues and adhesives. And it's been really hard. Scientists have found it really hard to even take the batteries apart to get to the minerals inside them. So they aren't particularly designed with recycling in mind. What manufacturers prioritize is having a nice, snazzy battery that's going to give you the highest possible range and performance. You could try putting the batteries to second use. Lots of people talk about using them as energy storage systems that you could install in your home as backup power and so on. But that brings its own set of problems because manufacturers have no control over a battery when it's put to a completely different use from what it was manufactured for. So what if I installed an EV battery in my garage and that blew up one day? Who am I going to be able to sue if the battery was defective? Is it the original manufacturer? Is it the person who repurposed my battery? Am I going to be able to have any protection if the battery went wrong? So again, we don't know. Car batteries are relatively easy to recycle because there are garages that will take your battery back. But if a battery goes into second use as an energy storage system, it might never come back into the recycling chain. And so there's a real worry that we might lose all of the minerals inside the battery if we put lots of them to second use. So how are we going to maintain environmental balance and circular economy goals? So really, proper end-of-life management is absolutely crucial for the environment and for human health. At the moment, nobody is terribly keen to get into EV battery recycling. There are no facilities up and running in the UK at the moment. They're being set up, but they're not ready to go yet. Nobody is particularly interested in EV battery recycling at the moment because EVs are relatively new and there aren't large enough numbers of batteries for this to be profitable. So there isn't the infrastructure. But one day, when enough numbers of batteries get old, which is going to be in about 5 to 7 years from now, we're suddenly going to be faced with a whole lot of batteries that we don't know how to manage. And it's going to be too late to start thinking about recycling only when the flows increase. So this is why policy is really crucial. The government and regulators need to step in and to incentivize people to get into EV battery recycling, even though there isn't a lot of profit right now. There might be in 5 years, but they need to begin doing this now. Because if you want to set up an EV battery recycling plant, you're not going to be able to do this at short notice. It takes anywhere from 2 to 5 years to get all the permission and the licensing to set up a recycling plant. And so we've got to start thinking about it before the problem happens. And this is why regulation is crucial. So the International Energy Agency estimates that by about 2030, we're going to have about 11 to 16 million tons of spent EV batteries that will be discarded. We're not quite sure how we're going to manage all of them. We haven't got the capacity to manage all of them. Like I said, there's various different pathways that lithium-ion batteries could be put to. You could recycle immediately after first use, or you could put it to some kind of second use as energy storage and then recycle it later. And not all car manufacturers agree about the best strategy. So for example, Nissan is very happy to engage with reuse of its batteries, turning them into energy storage systems. Tesla isn't quite so happy with the idea. They prefer their batteries to be recycled straight away after it's no longer useful in an EV. So there are barriers, like I said, to both pathways. Recycling these batteries isn't easy. Scientists are still trying to work out the best processes. The regulation isn't good enough. So there are targets, right? If you have a car battery, the target at the moment is you've got to recycle at least 50% of the battery. But this 50% is measured by weight. So it has to be just 50% of the weight of the battery has to be recycled. Now, what actually happens in practice is that just the packaging of the battery alone, the casing and the plastic and so on, that alone makes up 50% of the weight. So what manufacturers typically do is to use recycling methods that will help them to recycle the packaging in the outer, parts of the battery. they then discard all the really valuable stuff that's inside them. It doesn't give them any incentive to recover the nickel and the cobalt and the lithium. And so we end up losing all of that because the battery is essentially burnt down, and it's all the relatively useless plastic that's actually recycled. So we need cleverer recycling targets. We need recycling targets that actually focus on the components that we really want to bring back into the chain. So, you know, like I said, lots of technological barriers to recycling, lots of economic barriers. We haven't got the infrastructure. Lots and lots of materials are getting lost in our system because our regulations aren't good enough. And this isn't an EV problem alone. You know, less than 3% of rare earth materials are recycled worldwide. And we've got really crude battery recycling targets. Like I said, 50% by weight. So what is the solution? You know, the EU has come up with a pretty brilliant solution, I think, to this problem of being able to recycle the better material rather than the relatively worthless material. So the EU proposes new batteries regulations now. Instead of battery recyclers just having to target having to recycle 50% of the weight of the battery, they've got specific targets. This hasn't come into force yet, but is going to, later on in the year. They've got specific targets for how much nickel the battery recycler must be able to recover, how much cobalt they must be able to recover, how much lithium they must be able to recover. And so that then forces recyclers to focus on the materials that we're really worried about. So there's lots of things that regulation can do. Traditionally, we're always taught, you know, in the waste hierarchy, when we talk about waste management law, we're always taught that you must always look at reusing a product before you recycle it, because that's the way you get maximum value out of it. Does that really work for EVs, though? We're not quite sure. We might have to turn this round on its head when it comes to new products, because if a lot of our batteries went off into second use and didn't get recycled quickly, we might be left in a situation where those valuable materials are locked up for another 15 years. And we're then going to have to continue to mine for more material. We actually need some of that material to come back into the value chain. So we might have to rethink traditional principles of the waste hierarchy. This might be one product stream where it's better to recycle first before we recycle. Second use itself, you know, turning an EV battery into an energy storage system does not come without its risks. It's a pretty dangerous thing to do if it's not done properly. You need manufacturers who are going to take responsibility for that new repurposed battery, who are going to fit it properly into our homes. When I worked on the Faraday project, this was about 3 years ago, and one of our scientists who works on the safety aspects of EV batteries, he was contacted by the fire services, because what the fire services found was that somebody rang them up in Newcastle who'd taken an old EV battery off their car and installed it in their airing cupboard as a backup power device. Now, this was in this really hot airing cupboard. It was going to get overheated. And when lithium-ion batteries blow up, they blow up very, very badly. The fires can keep burning for up to 3 days. You can turn off the fire and it can reignite a few days later, and it lets out some really, really toxic gases, which can be quite fatal to us. And so there are no regulations in the UK at the moment to stop somebody from taking a used EV battery and installing it anywhere they want to in their house. There's nothing to stop it. There's nothing to say this installation's got to be done properly. And so we're, again, you know, opening up a lot of risks, not just to the person who's done it, but also to the neighboring properties, because that fire is going to spread. The smoke is going to spread and affect possibly bystanders. So we need clearer regulation to make sure that this is done safely when it's done. So the problem, of course, is how do we manage EV batteries both sustainably as well as safely, and what should regulators be doing? So in the UK, we're having an increasing problem of EV batteries blowing up in waste facilities, and this is just a little chart that shows how the numbers have been rising. So the number of fires that have been thought to be caused by lithium-ion batteries. Now, people still discard, you know, used lithium-ion batteries from their smartphones or laptops or small devices very unsafely in their trash. There have been 160 battery fires in waste facilities in the UK linked to lithium-ion batteries alone, and that number doubled from 2 years prior. So this is another problem that we're going to have to manage. The London Fire Brigade estimates that they attend on average 24 fires each week caused entirely by lithium-ion batteries, so the batteries that are in your phones and in your laptops. And these risks are going to be amplified for lithium-ion batteries that have been put to second use, because the longer you use a battery, the more likely it is to blow up. So what are the regulatory solutions for a circular economy? We need better critical materials governance if we want to continue to lead on towards a green revolution. And what we need, so what we typically, the word we use in regulation is the carrot and stick regulation. So you regulate both by taking the hard line on some issues and saying there are going to be fines and penalties if you don't comply. But there's also softer ways of regulating, where rather than go in very heavy-handedly, you give people incentives to do the right thing. This might be in the form of tax breaks or whatever, but you incentivize people to bring valuable materials back into the chain. One of the concepts that is used particularly for hazardous waste streams, a legal concept, is what's called the concept of extended producer responsibility. And this is essentially the polluter pays principle, where the person that manufactured the hazardous product also is given the responsibility for handling the product at the end of life. And this is applied to lots of hazardous waste streams like plastics and batteries and so on. But this principle needs to be robust and effective if we want to handle EV batteries properly. Permitting and licensing regimes, how do you find the right balance? So some people want permitting regimes to become really lax so that more and more people can be encouraged to come in and start doing business. But what values do you prioritize? Should that be lax enough that it compromises safety? Where do we draw the line between rigorous and enabling regulations? Extended producer responsibility, like I talked about, might be a very helpful mechanism to make sure not only that the polluter, the original manufacturer, handles their waste product, but it also encourages them to design their product to be easier to recycle, because then they've got a direct incentive to make a product that's going to be easy for them to manage at the end of life. Eco-design, and one of the things that we cannot stress enough is that you cannot think of recycling at the end of life of a product. You've got to think of recycling at the very beginning of a product. A product has to be designed for recycling. Who's going to want to do that unless there's a regulation or unless there's an incentive for them to do that? So end-of-life management has to begin at the start of a product, and regulation has a really important role in setting the standards that make people design products to recycle. What we really need is better liaison between scientists and regulators. We need evidence-based legal frameworks where regulators and scientists actually talk to each other and build frameworks and policies that make sense and that focus on efficient recovery of material. So good environmental regulation, going back to the original question, is really important. It protects, but it must be proportionate. It must create a level playing field for everybody. The people that take care of the environment shouldn't be disadvantaged because because their product isn't competitive. It should be transparent. It should be easy to carry out. So EVs, the reason I wanted to talk about EVs is because this is a really unique case example where we've got an opportunity to hardwire circular economy thinking right into the start of a product. We're at the very beginning of the EV revolution. This is a real opportunity to engineer a shift towards an economic model that doesn't just focus on economic values, but also takes into account the social and environmental values of new products. It is an opportunity that we shouldn't lose, because that could become an example for future product streams. So thank you very much.